Welcome everyone, back again on day two of Dev Apex Hours. Today we will be continuing from where we left off yesterday. Yesterday's session was about introduction to Apex, and we learned quite a few things, some of the basic constructs of, first of all, we learned how Apex as a programming language operates. What are the fundamental constructs of Apex? How do you write statements? How do you use things like loops and put decision control statements within the within a Apex program? Um, and of course, we learned a very important part of writing Apex programs, that is basically collections. Today we are going to. Yesterday was we were just trying to scratch the surface. Today we're going to pop the hood and try to dwell deep a little bit into some of these advanced concepts of Apex and how you can use some of the object-oriented paradigms within Apex, right? Uh, so so a quick introduction for people who've joined new today. My name is Jigar Shah. I'm active on the Stack Exchange and the Salesforce Stack Exchange, to be precise, and the dev community. I'm a Dreamforce 2019 speaker. I've got a couple of certifications under my belt, and I am the co-organizer of Apex Hours and Part to Code. I blog at learnsfdcwithjigar.wordpress.com. Jigar Shah 189 is my LinkedIn and Twitter handle. So feel free to reach out to me even after the session with your questions. I will be more than happy to help you. Some housekeeping rules before we, start the session. Please mute your mic. Remain enthusiastic and keep asking questions. The Apex Hour team members are on the call right now while I present. And we will be more than happy to answer your questions. You can post your questions in the Zoom chat window and your questions will be answered. Please do not shy away from asking questions. No questions are silly. Although we will answer questions during the presentation, but we will also try to attend any unanswered questions in the last 10 to 15 minutes of the sessions. Just in case if you're not able to do that, you can always go to the website, to our website, which is apexhours.com. Look for the post of the respective session and put a comment or a question there in the comment section, and we will respond to your questions. So feel free to do that. Make the most of this opportunity. So today we're going to be learning about some of the advanced concepts of Apex. Yesterday we were just writing procedural code. Today we're going to be learning about what exactly is a class, how can you implement a class, and then there are other variants or other elements that a class has, which are methods, and these methods come in various flavors. Then there is an important concept that we're going to be talking about, which is pass by value and pass by reference, something that is true for other programming languages as well. And last but not the least, we will see techniques to extend a class using interfaces and using the other tools that are available in the platform, so as you can really write not just plain simple classes, but really write good object-oriented code. And as a part of being a Salesforce developer, when you write Apex, a lot of these concepts come into play. So let's see how Apex really offers these features and what are the constructs required to understand and implement each of these features. So the most fundamental element of any programming language has always been, so initially there was procedural programming where you would just write simple lines of statements one after the other and they would execute, right? over a period of time, that particular paradigm changed, and there was something which was introduced to the world called as object-oriented programming, right? So basically, object-oriented programming, everything, uh, every aspect, every element of the program is treated as an object. But before we go and see what an object is, we need to understand what a class is, because that will help us get a very clear understanding of how objects relate to classes, and what is the relationship between them. So a class is nothing but a basic user defined data type. So yesterday we spoke about a lot of primitive data types, right? We spoke about data types like strings, integers, long, strings, binary large objects, record identifiers. All those data types are basically termed as primitive data types, and any kind of um, programming language has primitive data types. However, those primitive data types are not enough, because the real world is really complex. You could have a combination of all those primitive data types kind of bundled up into one single data type, which is more user defined. And such kind of data types, which are user defined, are called as complex types, right? And they are nothing but basically classes. So each class is basically nothing but a complex type. So whenever you go looking at the developer guide or any kind of documentation, and you hear the word complex type, it is referring to a class. Okay, it's not referring to any kind of straightforward primitive data type. Now, the reason why we write classes is because class is nothing but a template, or you can just call it as a blueprint, which defines the behavior of the object, right? And if you essentially understand, so as a Salesforce developer, while you're writing Apex, um, majority of the times when you're writing Apex, you would either end up writing an Apex class or an Apex trigger. So today we are going to limit the discussion only to Apex classes, right? Um, so what exactly does a class contain? A class is basic. A class basically comprises of three basic types of element. So there is a constructor. There are member variables which define the state, and then there are member functions or methods which define the behavior. So every class is basically a bundle of all these things. Constructors are typically used for memory allocation and initialization. Member variables are nothing but variables. So we were in our yesterday's session, we defined a lot of different types of variables, and we were just defining them within the execute anonymous window. However, those variables cannot just exist independently, right? We were able to write variables yesterday because we were using an execute anonymous block, but variables cannot exist independently, and they need to be wrapped up within a class for them to exist. Um, Last piece of understanding a class, and the most important aspect, is a class is a static entity, right? However, an object is not a static entity, and hence an object, anything that is not static or is changing, always has something that defines the behavior, or the behavior is what uh, results in the change. And that is exactly the reason why we define functions within a class, because functions are what define and govern the behavior of that class. So typically, if you would see uh, a class right here, or a class, typically Apex class would have the following syntax, which is here. Now there are quite a few terms over here, and we will see each of these terms over the course of the session. uh, but for simplicity's sake, there are very basic things that you need to know. So there is, of course, a class is defined by or a prefixed by the class keyword. This is a standard keyword that is provided by Apex, and this keyword basically defines or helps the Apex runtime determine that this text which is written after immediately after this class keyword is the class name. All right, and there is an open brace, curly brace, and a closing curly brace. This basically defines the body of the class. Okay, so there is the class keyword, there is the name to the class, and then there is the body. And we will see how to define what goes inside the body. So the body typically comprises of the state and the behavior, which is typically nothing but member variables and member functions. Okay, now let me talk a little bit about some of these top keywords which are there in line one, which is private, public, and global. uh, Yesterday, if you recall, where I was explaining the blueprint of any programming language, there was an aspect of security, right? Um, and while we write object oriented code, we also need to ensure that classes or elements and functions of a class are secured and accessed by only the desired set of lines of code or other classes, right? So basically you write one class and then there is another class and they start talking to each other as a part of your program, and we'll see how that happens. However, as somebody who's defining a class, you want to make sure that the control of being able to access variables or being able to modify those variables based on the behavior is limited and constrained. And that's exactly why uh, these keywords are mentioned. So these keywords are termed as access specifiers, and there are three basic access specifiers in Apex. There is private, there is public, and there is global. So a private access specifier means that a, a, a private class can be accessed locally, and a private variable can only be accessed by, I'm sorry, and a private variable can only be accessed by member functions of the same class. Okay, so let's say if I had class 1 and class 2, um, only a member function of class 1 would be able to access the private member variables of class 1. All right. Similarly, there is something called as public. Public, the name itself suggests that everybody can access everything, which means that if you're marking the class as public, or if you're marking the member variables as public, or if you're marking the member functions as public, okay, um, let's go back and take the typical example which I mentioned a while ago, which is class 1 and class 2. So class 2, if everything is marked as public in class 1, class 2 member variables and class 2 functions can access the member variables of class 1. Okay, right? So basically in public mode, everything is accessible to everybody. Global is an advanced concept, and that is typically used when you are writing managed packages. Okay, with just like you could build executables on for Windows or for Mac, which kind of are a bundle of certain set of functionalities, and you could install and set them up. Similarly, there is something called as managed packages also that can be created and can be installed and set up on for a specific Salesforce org. So this global context really comes when a managed package comes in picture. Every managed package is typically accessed independently or can be identified uniquely via a namespace. Namespace is a typical string which identifies a package uniquely. Okay, uh, a, a global when you mark a class as global, or when you mark a method as global, the method or that class is not only accessible and limited to that particular package, right? Just like, and think of it as an, think of a package as an exe, right? You can't really make changes to the code of that exe, right? But if there was some class in that exe which was marked as global, right, and you could refer to the documentation and say, oh, there's a class here, you can actually extend that class, or that class is accessible to you only because it is marked as global. So basically, when namespaces come into consideration, okay, global helps uh, member functions or classes or member variables, so marking them as global makes them available for access across namespaces. Okay. All right, so that is about what a class is. More, let's move on to understand what is the correlation of a class and an object. So basically, an object is nothing but an instance of a class. So you can simply call it as a class in action, right? So when you write a class, you define the template and the blueprint, right? And then when you, and then there is a process that you will carry out, and we'll talk about that in a bit. But when that class actually runs, it gets created as an instance, and that instance is generally referred to as an object. Now please don't confuse yourselves with the term object, because when we're in the Salesforce world, object is typically referred to, or is very as analogous to a database table. But this is not that object that I'm referring to. It's basically an instance. So from now on, for an object, I would really be terming it as an instance. And when I say the term object, it basically means that I'm referring to a database object, or a database table, or a standard, or a custom object. Okay, so this is the instance of a class, right? Now, how does a class turn into an instance? So there is a process called as instantiation, right? And the way you do it is, once you define a class, right, there is a new keyword that you use to tell the Apex runtime that, hey, you need to allocate memory on your server for this particular class, right? And that's when the Apex runtime understands that, and it performs a memory allocation for the class based on the defined data types and the methods, and the processes, right? And when you start using that particular instance as a part of your program, you will have a state, you will store values, you will store numbers, strings, different types of values in these particular variables. And any, the values in an instance at a given point in time define the state of a instance. Okay, so basically, an instance is nothing but a class in action. And how do you instantiate a class? Through the instantiation process, which is uh, you which is more like variable declaration, because a class is nothing but a complex type. So you define the data type. So data type here is going to be my class, right, because it is a user defined data type. And then you give the data type a variable name, right, which you're going to use temporarily. You're going to use the equal to operator and the new keyword. The new keyword results in an instantiation, and that allocates memory. So this is the overall how a class can be transformed into an instance. Now, one of the other things that is very important as a concept is basically methods. Okay, and like I said, Apex develop or Salesforce developers most of the time not only write classes, but they uh, define behavior of the classes by adding methods to them. So what are methods? Methods are nothing but the reusable code snippets which have a very specific purpose. Okay, ideally they're supposed to do a single job, but or for example, adding of two numbers, or multiplying two numbers, or concatenating two strings. This is a very specific purpose that you have defined, and that's what a method is supposed to do. uh, it exactly knows what is coming in, and it exactly knows what is going out. So typically when you define a method, there are, again, you have the access specifiers here, right? And then there is a name that you define to that particular method, and then there are input parameters. Okay, so the name could be anything, right? Based on your need. It is always recommended that the name should ideally be a verb in the English language and should clearly communicate the purpose of uh, or clearly communicate the behavior of that method. For example, add numbers or concatenate strings, or you can just say concatenate. So that ways, just by looking at the name, you come to know that a method is this is you just get to know the purpose of the method just by looking at it. And then there are, of course, input parameters that you can add. So when I said that the method exactly knows what comes in, because at if you remember yesterday, Apex is a strongly typed language, which means that the type of data that you're interacting with has to be defined beforehand, at compile time. And that's the reason why you would also specify, not only say that num1 and num2 is coming or is being provided to the method, but you also say what type does it belong to. And in this case, in this particular example, it's an integer, right? Uh, a method like a class also has a body, right? So a class's body comprises of member variables, right? Or just variables, right? And then the body of the class also comprises of methods, and the methods themselves have bodies which contain instructions or statements, which define the behavior of that method. Okay, so far so good. I think that brings us to our first demo, which is demo one, and we're going to be seeing how you can write your first class and a simple method. Now, yesterday we wrote a basic hello world program, right? So first of all, let me switch back to my Salesforce instance. Uh, okay, let me quickly, guys, just give me a minute. I'm going to pause my screen for a second. And I'm back. So I have my developer edition instance over here. And what I'm going to do is, so for people who don't really know how to get a developer edition instance, you can go to developer.salesforce.com, and you can sign up, use the sign up option. That will basically help you. I'm just trying to make the window a little smaller, so hopefully you guys, and that will bring up this particular sign up form, and that is here you can provide your details and sign up, and which will send out an email to you, sending you a link and asking you to put in the password, and that becomes your own very developer free lifetime free developer instance, where you can practice all the code and all the assignments that we are doing. Okay, this is available free of cost, and it is available for the complete lifetime. Make sure you use developer.salesforce.com and you don't go to salesforce.com, because that is a 30-day trial and it expires in 30 days. Okay. So so switching back to my Salesforce instance. So now I've already done the sign up process. Here's my Salesforce instance. I'm going to go to setup, which is this gear icon, and use the developer console. Developer console is an online editor which is provided by Salesforce, and it comes as a part of the Salesforce instance. This allows you to write code and test a lot of things. There's already some code, so let's just close the tabs. And let's write our very first class and a method, right? So if I have to create a class, what I'm going to do is I'm going to use file and go and say new, and then I'm going to say Apex class. So I'm going to say create a new Apex class. And the first thing it's going to do is ask me for a name. Now I'm going to name my class demo1 over here. Okay. And say okay. And that is going to generate a class file. which has an extension of .apxc. This file is stored on your Salesforce instance. Okay, so if you want to, so let me just save this for now, or let me just write the code and then I'll show you how to see what are where, how to go and access the classes that are stored in your Salesforce org. So this uh, this is how you create your first or your class in Apex. So there is an access specifier. I'm saying public because I want this to be accessible for now. I'm going to use the class keyword, and then I'm going to use the name of the class. uh, in addition to that, we are also going to add a method to this particular class. It's a very simple method, right? And I'll tell you what this particular code snippet is doing. So this particular method here has again an access specifier which says that this method can be accessed by other classes which reside outside this particular class. The term void basically means that this method is not returning anything. Okay, and this is the particular name of the method, and this is an input parameter to the method. So I'm saying that this input parameter is of type string, which means that this method is always going to provide a type of expect a type of string. Now what I'm going to do is simply save this. Okay, and classes, one of the things to understand is classes cannot run or execute by themselves. You need some kind of invocation mechanism to have the class, or to ensure that the class runs. So in order to simulate or emulate the invocation, what we're going to do is we're going to open the execute anonymous window here, and I'm going to simply invoke the class. Now how are we going to invoke the class? Simply by using the new operator. So I'm going to say demo d1. So I've defined a custom complex type, which is and the type name is demo1. I'm going to give it a name called d1. I'm going to use the equal to operator, and I'm going to say new, which tells the Apex runtime that, hey, allocate some memory to this data type or demo1, right? And I'm going to say new demo1. Now the thing that happens is, the reason why we demonstrate or we write demo1 again and use a circular set of braces is because this here invokes the constructor of a class. Okay. Now if you see that there is no constructor over here, right? There is nothing that I have defined, but it will still invoke a constructor. One of the things to understand is, whenever you write a class, every class has a default constructor. Okay, so even if you don't see anything, there is a constructor which is associated with the class and which helps the uh, uh, memory to be allocated, and that process is called as initialization. Now what I'm going to do is I'm going to use my variable that I created, which is d1, and I'm going to call the method here, which is print output. Right now, if I say execute, the Apex runtime is going to intimate me that, hey, you're doing something wrong. So let's see if it does that. And if once I said execute, it tells me that the method does not exist or incorrect signature. So basically, the arguments, input arguments that are passed to the method and the return types together are collectively known as the signature of a method, which means what this error message is trying to say is, I do not understand what method you are trying to call, because the signature that you are trying to provide for the method and the signature that I have do not match. Okay, which in simple word means that, hey, by the way, I expect a string, but you're not providing anything, so I'm confused, and that's the reason why I cannot allow you to do it. So what I'm going to do is I'm going to give it something which it asks for. So in order to provide a string, all you have to do is single quotes, and that's how you can add a string literal. And now when I say execute, what will happen is the program executed successfully and it generated a debug log. Now let's see if the string we passed as a parameter it actually got displayed and written to the debug log using the system.debug, which means that with while when you start using methods, it makes your code more reusable, because now earlier in the earlier way of writing, we wouldn't be able to use the same method to uh, uh, to do the same thing from multiple places. We would have to instantiate or write variables now and then, but with a method you can make the code reusable. Again, this is has a very specific purpose, and the purpose of the method is to print something to the debug log, and that's what it's exactly doing. Okay, so this is your very first class and method. This is how you simply define a class and a method in Apex. All right, fairly straightforward. Let's go back uh, to the presentation. Now, after understanding how to write a class and a method, there are certain advanced concepts that we need to learn about, which is static versus instance. So you'll often see this and hear these keywords. So there could be static variables and methods, and there could be instance variables and methods. And what is the difference? So let me talk about that a little bit. Uh, Static variables or and methods are very class based, which means that in order for them to allocate, for memory to be allocated for them, you don't really need to use the new operator or the new keyword. As soon as a class is loaded in the memory of your Apex runtime for your org, uh, the class variables and methods, they will be allocated memory. However, with instance variables and methods, that's not true, because they are object based, right? Which means that you have to explicitly make a new call in order to allocate memory to the instance variables, right? One of the other thing is, if you talk about replication, static variables and methods do not replicate, which means they only exist once per class. However, instance variables and methods uh, can be replicated. So basically, the number of instances that you create for a class are the number of times those variables, copies of those variables and methods will end up being created, right? And static variables and methods are initialized when the class loads. When I said initialized, memory is allocated, but with instance methods, it's basically done when a new statement, or when you say type equal to new and call the constructor. So this is the basic syntax of making a call to a static method, right? Static methods are defined. When you define a static method, there is something called as a static keyword which is used, and we'll see how to use that. So this is typically how you would invoke a static method. You see that there is no new keyword being used. However, in an instance method, you have defined a class and you're using a new keyword to define the memory for a class, and then you're using the variable that you declared of that complex type to invoke the method of that particular class. So very straightforward, fairly simple, but of essence when you write programs. Okay, when you want elements, or when you want multiple copies, or the behavior to vary based on an instance, then you would basically go with instance methods. Most of the times you would write a lot of instance methods. But when you write things like a utility method, for example, you want to take an input string and generate a simple comma separated string. Now, irrespective of the type of string, you will just generate a simple comma separated value based string. Such kind of methods are typically called as utility classes and utility methods. And these kind of methods would actually be defined as static methods. Okay. So that brings me to my second demo. And let me just go back and switch to my Salesforce screen. So let's just close off. Before I do that, let me also show you where and how this class got created. So now I am in the setup window of my Salesforce instance. If I want to look at what all classes exist on my Salesforce org, I'm going to go to setup, which I'm already here, and then I'm going to go to quick find and type in Apex. and that kind of shows me the Apex, a lot of things. Let's not worry about all these things, but today, because we're talking about classes, we will be looking at the Apex classes option. I click on that, and that kind of renders a list of all the Apex classes that exist on my org. And if you see demo one, the class that we created right now, of course I've created some other classes on this particular instance also, and that's the reason why you see them. uh, uh, but there is a demo one class which is already there, and once I click the demo one class, I can actually see the code written within that demo one. Okay. You can actually download this particular class, right? And also see, what all dependencies this class has. In this case right now, because it's a very straightforward class, it doesn't really have any dependencies. One other key thing to understand is every class has a version. So remember when Salesforce says that everything is auto upgraded, or you can really control which version you want your code to execute on. So it is really referring to this version. So this version maps to the Salesforce API version, and that kind of tells the Apex runtime what API versions to use. There could be certain features which work only with certain API versions, so you got to be careful. The general behavior is when you end up creating a class, the most recent version is used, but you can either go and edit it from here by clicking the edit button and go into the version settings and changing this drop down right here, or you can simply go to the developer console. Let me just open up that file and say demo one, and you could change it from here also. So it's basically the same. All right. So this is how you would typically access classes on your Salesforce instance, or see where the classes are stored. Now let's go back to our demo 2, which is nothing but a demonstration of static versus instance variables and methods. So I have a small program which is already ready. I'm going to So as usual, I'm asking for a creation of a new class, and I'm going to name it demo2, and then I'm going to say, okay, that creates a class. Now I'm going to just wipe this and overwrite it with my code here. And let me walk you through what exactly this is. All right. So I have written a public class named demo2, right? I am defining two basic variables. There is a static variable right here which is called as um, uh, a constant, right? And then there is an instance variable. So do you see the difference, that there is the constant or the static variable has a static keyword in it, but the instance variable has no keyword. So basically this is how you would typically differentiate just by looking at the variable, saying that what is a static variable versus what is an instance variable. So this is the declaration piece of the variable, right? Now these variables are going to be used somewhere in the code, so let's go and see that. Now the other important thing is a static initializer block, and which is what is there, right? So a static initializer block is a piece of code. It has this specific syntax where it just uses the keyword and the open and close curly braces. This block runs only once when the class is loaded. Okay, so if you have a requirement for writing code which runs only once initially when your class is loaded, then you might want to put it in the static block. All right. uh, what I am doing over here is using this constant and assigning it a default value. So I'm saying this is the default value that you need to have. Beyond this, I have two constructors. So this right here is one of my constructors. Sorry about that. Uh, what I'm typically doing is just adding comments. So if you want to add comments just to make your code more readable, you can use a double forward slash. Another way of adding comments is also using, if you want to do multi-line comments, you can use slash and an asterisk and a closing asterisk and a slash. So these are the two ways in which you can add comments. Typically, if you're doing single line comments, you would just do it this way. So this is one of the constructors, right, which I have. And then there is another constructor, which is an overloaded constructor, right? So, and I'll explain to you what we're trying to achieve over here, but let's look at this by piece, and that will give you a perspective. So the overloaded constructor is actually taking an argument of type string, and anybody, because these constructors are public, anybody can invoke them from outside. Okay, anybody can invoke them from outside the class, right? So what I'm doing in this particular constructor is whatever whosoever is invoking this particular constructor, the value that is being passed to this constructor is actually being stored in an instance variable. Now, one of the things to note over here is you can use the this keyword to refer to the current instance of the class. Okay, so this is one way of saying that this keyword refers to the current instance of the class. Now, what I'm really doing is the string that was passed, I'm assigning it to the hello world string, and it is going to be stored as the uh, within this particular class. So this right here are your member variables. This right here is your static initializer block. So these are instance member variables, and these are static member variables. Okay. And what I've done is, here is what you have as a method. And this method is typically an instance method which tells that okay, let me just look at the error. We'll come to the error in a minute. But this is basically a static method that I've defined. And if you see, anything that you define as static needs to have the static keyword prefix to it. And this is printing something. It's just printing an output to the debug log. Now there is an error that you see, right? And the error is telling me in the problems window, which says that this cannot be referenced in a static context, which means that this keyword will not work when you are using static methods, which means that I need to and I'm going to save that. Okay, it says hello world. Okay, let me just quickly check that what's happening. So I have a string to display. The string to display is being assigned to this dot hello world, and I'm using. So for now, for a moment, I'm just going to use it as an instance method, right? We'll look at how to change. We will look at a static method example shortly. Okay. So
can you make that variable public?
Sorry, this one.
Yeah.
Yep. Okay. So I have an instance method, a constructor, an overloaded constructor. So what's going to happen is, when I do a new call now, I can either invoke the default constructor or I can invoke the overloaded constructor based on whether I pass a parameter input argument to this constructor. The runtime is intelligent enough to understand whether to invoke this or whether to invoke this particular constructor. If I'm invoking a default constructor, it's going to use the this keyword and initialize or hold basically it's internally going to call the overloaded constructor. Basically this statement will basically call this particular statement right here, and this will basically pass the default string, which is hello world, and this hello world value will get stored in the hello world variable. Okay. I know it is a little bit confusing, but try to just get a hold of this. So if I invoke a default constructor, right, without any parameters, it the constructor will execute it's internally, because I made a call over here, that this keyword understands, and because there's a parameter, will internally point to the instance, and based on whether I've passed a parameter, it will call this particular overloaded constructor. This overloaded constructor will assign the value that was passed to it, and because the value was that of the default string which got initialized when through the static initializer block, and that eventually gets stored in the hello world string. And what is going to happen is, once you do a print output, it is going to output the hello world string. So let's just see this in action. Let's just invoke this particular class. Okay, so I'm going to say demo2 because my class name is demo2. Okay, and I'm going to use the new keyword, right? And now when I say demo2, and I'm going to say print output, I'm going to just remove the parameter here. Okay. In this case, the output that should be printed is going to be hello world. Okay, so let's see. So I just run this, and what gets actually printed is going to be hello world. Okay. However, let's make slight modifications to this, and then today, now what we're going to do is just again create a new instance, right? But this time I'm going to pass an explicit string instead, and I'm going to say hello Jigar. Okay, and I'm going to initiate the print output method, right, through which is an instance method, right? And now if you see, the output that should get printed would be hello Jigar instead of hello world. Okay, so you can actually control the behavior of the method based on the input that you are giving to the method, and that is what I'm trying to demonstrate, along with the use of a instance method. So these are all instance methods. So I'm going to say execute now. I'm going to remove this for now so that you get to know what exactly is happening. And the program executed successfully, and this time it should be hello Jigar, which got printed to the debug log. So based on what I passed to the method, based on the input parameter, the runtime was able to decipher which constructor to call, whether to call a default constructor or whether to call an overloaded constructor, right? Now, let me just add another simple method, a static method, just to showcase how you can call a static method. So I'm just going to close this and make small set of quick changes to this method. Okay, so I'm just going to call it with a different name. I'm going to say, and I'm going to just say uh, display from static method. Okay, and I'm going to remove the string for a while. This is a static method. So I just won't have to make sure that I'm saving my code. We control S, the code is saving and it's ready for execution. So now let me go back to, so all I did was added a new static method. And I'm going to demonstrate how we can call a static method now. Now, if you want to call a static method, you don't really need an instance, which is D2 in this case. All you have to do is use the class name, which is demo2, and the static method name, and it should print an output. So if you see, there were two outputs. There is one which came through because the overloaded constructor was called, and the other one because the static method was initiated by a call through the class name. So this is how you basically instantiate a static method and instantiate, or sorry, how you invoke a static method and how you invoke an instance method. So this is how you do it in Apex. All right, let me switch back. We have a couple of other concepts that we need to understand quickly. So we looked at static and instance variables and methods. Now there is one beautiful concept that is there, which we need to understand as a part of our programming language and as a part of object-oriented programming. Is when you pass values to, or when you pass input arguments to a method, there are two ways in which you can do that, right? One, you could pass them by reference, and second, where you could pass them. So next, I'm going to be talking about a very important concept, which is called as pass by value and pass by reference. So when we pass parameters or input parameters to methods, there are two ways in which those parameters can be passed. One of the techniques is called as pass by value, while the other technique is called as pass by reference. And let me just explain the difference between these two techniques of passing input parameters to any method written in Apex. The pass by value technique is usually applicable and relevant to primitive data types. So all primitive data types are always passed by value. And what does that mean? It means that, let's say, if I have an integer variable, or an integer variable that I'm trying to pass to a method, uh, that primitive data type, that variable itself does not get passed to the input method. However, a copy of that variable is created and is passed to that particular method, which means that any changes that happen to that method happen on a copy of the variable and not the actual variable itself. So in this example, if you see, a cup that is being passed to the fill cup method is actually nothing but a copy of the original cup. Hence, any coffee that gets filled in the cup via the fill cup method is actually being filled into the copy of that cup and not the original cup itself. The second technique of passing parameters to an input method, or to a method in Apex, is called as pass by reference. In this technique, the this technique is slightly different as compared to pass by value. In pass by value, a copy of the variable is created and sent over into the method. However, in pass by reference, the actual variable itself is sent over to the method, which means that now any changes that happen on that variable within the scope of the method are actually the change are actually happening on the original variable and not a copy of that particular variable. So let me demonstrate this very quickly with the help of an example. Let me switch back over to my Salesforce instance. So what I have here is a very simple class called demo3, and there are four methods. There is a main value method, which is in turn making a call to the pass by value call method, and then there is a main reference method, which is making a call to the pass by reference call method. The main value method has a string variable, which is a primitive data type, and that value is being passed to the pass by value call. Now, since it's a primitive data type, it's a pass by value call, which means when when this when this variable is sent over to the pass by value call through this particular call, actually a variable of the actual website URL variable here, a copy of the variable is created and that's being passed over to the method. Hence, any change to this particular variable is only limited, or any change that is incurred to the website URL value is limited to the scope of the pass by value call method, which means that if I run the code, you will see that even in the before value call statement as well as in the after value call statement, the website URL value will remain unchanged in spite of it. There is an attempt to change that value within the pass by value call. So let me just quickly demonstrate this. For demonstration purposes, I'm just going to comment out the code here and only run the pass by value call code. So let me just go and make a quick call to the pass by call method, and I'm just going to say execute. So the code ran successfully, and now if I just go to the debug log and use the debug only filter, you'd see the value before and value after remains unchanged in spite of the attempt to make a change by calling the method within the pass by value call method. Right now, this clearly demonstrates that a copy of the string variable website URL was created before it was passed to the pass by value call method, and hence the change to the variable only was limited to the scope of the calling method called method. Now let me demonstrate the pass by reference call. In the pass by reference call, instead of creating a copy of the input variable, the actual variable is being passed, which means that in this case, I'm actually passing an account instance. An account, think of account here as a class, and this class is actually provided by the framework, by the customer 360 or the lightning platform, whatever you want to call it as. This class, the definition of this class is already written there, and I'm just going to make instantiate that call. Now this is a complex type, which means that uh, uh, and it's a non-primitive type. So any complex type is basically a non-primitive type, and this non-primitive type, when sent over to the method, is actually sent via a pass by reference call, which means that in this case, when I run the method, the instead of the copy, the actual variable is being sent, which means that any change made here would reflect back, and the URL would the website value for the account field would uh, the website field value for the account object would change. So let me just demonstrate this. So before that, I'm going to make a quick save because I made changes by uncommenting the code. And now I'm going to go back and open the execute anonymous window, and then just uncomment the call to the main reference method and say execute. Now this results in a successful execution, and let's see what what gets printed to the debug log. So in this case, what really gets printed is the first two statements are from the pass by value call method, and you see that the value is not being changed because a copy was passed over as the input argument to the called method. However, it was it a copy was passed actually. However, in a pass by reference call, the actual variable instead of the copy was being passed, and hence the change was the change kind of percolated over to the original variable, and hence the website value has changed. So this helps us understand how pass by value and pass by reference techniques can be used to pass variables as input parameters to the methods. With that, I will switch over to my next slide. And so think of it this way. When most of the times when you build products or when you write code, there are certain things that you are aware about, but there are certain things that you may not be very clear on. And that is the reason why you often feel the need of writing such kind of special classes that can be extended by people. So you give them part of the functionality. However, some of the even if they want to override that functionality, they should be able to do that and include that functionality. For example, if you wrote uh, a method or a class to print a certain output, right? Maybe print stars. However, the other person who's trying to use that particular method wants to alter that behavior without having to go and change the source code or the code that you have written, right? That this kind of a behavior is possible, and you can actually do that using virtual, writing virtual classes and using the override functionality. So basically, uh, you can extend a class using the virtual, or you can make a class extensible using the virtual keyword, right? Basically, what you typically do is mark the class as virtual. In this particular case, we have an example here. So there is a class called marker, which is writing something, and this class has been marked as virtual. And there are two methods within that class. There is one method which is write, and the other method which is discount, and those two methods are also marked as virtual. Now the reason why you mark, when you mark a method as virtual, it is basically somebody can override or change the behavior of that method without really having to change the code that you have written. Okay, so in that case, what you have to do is you have to write a child class. Okay, and this child class extends the parent class, and within, so this is the syntax where you say you have the access specifier, the class name, the class keyword and the class name, and then there is an extends keyword. So this extends keyword is of importance. The extends keyword defines that, or tells the runtime that hey, the class that is being written is going to extend the earlier or any existing parent class, and that class is marker. Okay, only classes marked as virtual can be extended, other classes cannot be extended, right? And then what you start doing is, once you do that, you will have to keep the method name same, but you can use the override keyword, right? And you can define your own behavior in that. So when you make a call and instantiate, and when you instantiate the right method, it will use, or it will output uh, the behavior that you have defined. Okay. However, if you instantiate and output, instantiate the parent class or the virtual class, it will give you the behavior that was defined in the virtual class, right? So I'm going to, I think that brings me to my demonstration 4, which is about extending a class. All right, so I'm going to quickly go back to my developer console, and this time we're going to create a couple of classes. For this demonstration, I'm going to create a couple of classes. For the first class that I'm going to create is called as a string writer. It just writes a string to the debug log. And what this, so this is actually the parent class, right? And this phenomenon, this behavior of you being able to override the method, okay, is called as polymorphism. Okay, uh, where you have the same name but the behavior is different. Okay, so one name, multiple forms, polymorphic, multiple forms. So what I've done is I've defined a basic class, marked it as virtual, and then I've defined a print string, which is printing some kind of default string to the debug log, right? I'm going to save this particular class here, and now I'm going to write another class which is going to extend this class, right? And here, so this class, I'm going to call it as an HTML string writer. So I want this class to write HTML strings. Okay, and I'm going to use this class to extend. So I'm going to extend this class over here. So the HTML string writer use the extends keyword and extends the string writer class, and it also has a print string, right? And this method prints an HTML string with the angular bracket p tags, which is the paragraph tags in HTML. So I'm going to save this method. Now I'm going to go to the to the execute anonymous window and make a call to both these classes, right? The extended class, and you see that I have making the call to the same method, but the behavior is now different. So basically I have altered the behavior without really making changes to the code of the string writer. So let's see if this actually works. So I'm going to say go execute, and this is going to print first time because I'm making a call to the parent or the virtual class. It's actually printing the default string. However, if because I wanted to change that behavior, I made a call to the string writer which extended this class and changed the behavior, and instead of printing the default string, it is printing a HTML string. So this is how you can actually change or induce the behavior of, or the ability to change a class without really having to, without really going and changing the source code. Okay, last but not the least, we have something called as interfaces, which are extremely important. So interfaces are nothing but contracts, right? So let's say you're developing a product, okay, and then their product requires some kind of discount calculation, okay. uh, by default, your product can only provide 5% discount. Okay. Now, once you deploy and ship the product towards this to the customer instance, you want the customer to be able to define their own to be able to define their discount, but you also want to make it a mandate to be that they should always define a discount. Then in that case, you know, if you want to do this kind of a functionality and invoke or put a mandate, you basically need an interface. So basically interface is a contract that enforces that the child class, whichever is implementing that interface, so you implement an interface and you extend a class. Okay. Keep this thing in mind. So whatever class, child class, is implementing an interface, only that class can be invoked. You cannot really invoke an interface, right? uh, and basically an interface contains only uh, the declarations. It doesn't really contain the body. So even if you try to include a body, it'll you know, the runtime will give you an error. So let's just see a very quick example of how you can define an interface and how you can use those interfaces to put a mandate to people using that interfaces within Apex. So I'll quickly switch back to my Salesforce instance. I'm going to close all the tabs right here. And now I'm going to define a new interface. So even if when you're doing a new interface, you don't really get an option of saying new interface, you just say new Apex class, right? Uh, and what we're going to do is we're going to define an interface, and I'm going to call it an area calculator, right? Now, one of the things which generally is a notation, industry notation, is whenever you write interfaces, prefix them with a capital I. That signifies also, anybody looking at the name can easily make out just by looking at the name that this is an interface. So although it says public class in I area calculator, I'm going to change that keyword and say interface. All right. So instead of a class, you are now using an interface. And what you're going to do is define a method body in that interface. And we have a method called as compute area, right? You don't need to put an access specifier. The reason is because all the methods in an interface are public, which means they should be accessible. Otherwise, nobody's going to be able to implement it. So I'm going to save my interface. So this is how you create an interface in Apex. Now, what you're simply going to do is write a new class. So now whoever wants to implement a area calculator would really have to provide the definition for the compute area, which means that this is a mandate that will be enforced on anybody who's implementing this particular interface. So I'm going to create another class which is square area calculator, and this class is going to implement my I area calculator. Right. And now I can of course define a constructor. Sorry about that. But let's say if I do not define a method over here, right? If I just say, for example, if I'm not trying to implement a method, the runtime is automatically telling me that the square area calculator must implement the compute area method. And this is how I am mandated or enforced to implement the method. So if you ever have a situation in your code where you want somebody to want to mandate implementation, or want them to mandate or want to mandate the defining a behavior, then you have to use an interface, right? uh, so what we're going to simply do is I'm just going to copy the complete class. Okay, so I have defined the compute area method, and now if I save, the error should go away. So now the runtime knows that I have defined or provided a body for the compute area method, right? Now I've defined the interface, I've defined the class that implements the interface. Now basically the way you can only call it is so one of the ways in which you can instantiate the class is by assigning the type of the child class to the parent class, right? And right. So in this case, it will be compute area, right? Right. And I so basically in this, sorry about that. I'm going to say SAC, which is the instance, and I'm going to say compute area. So just by knowing the type which is provided over here, it is going to, the runtime is capable of understanding which method to call. It's going to make a call to the compute area method. So similarly, if you want to extend it, saying, if the area calculator has multiple versions where you want to do a square area calculator and a circle area calculator, you can just implement the interface and provide various definitions. And based on the instance that was assigned, uh, that instance method gets called, which allows you to include runtime polymorphism into your code and makes your code more flexible and extensible. Okay, so I think that brings us to the end of the session. These were some heavy concepts that we learned today. I know it's difficult to digest it in a single hour. You will have to go back and do practice and reiterate on these concepts so that you can master them. But last but not the least, you have there are some Trailhead badges which you can do. So there is an object-oriented programming for admins, which is a great start to understand the. So some of these aspects which we talked about, static versus instance, or polymorphism or inheritance, all those things can you can learn easily via the object-oriented programming for admins module. Then there is also a developer console basics module, which is typically gives you a know-how of how to use the console. And when you say developer console, this is how it is. So there are many hidden gems and many capabilities in this particular console. Because you're going to be using this as a tool, it is important for you to know the nitty-gritties of this tool, and hence this developer console basics badge will come in handy. These are some of the additional references that I have as a recommendation: the developer guide, the governor limits, and the Trailhead module. And uh, I have the assignment for the day. So today's assignment is going to be about writing an Apex class called Math Calculator that performs arithmetic operations on integers based on the following methods. Uh, on the input numbers that get passed to them as arguments. Okay, so basically there is add and there is multiply. Add kind of sums the input arguments and returns the summation. Multiply method multiplies the two numbers, two arguments, and returns the product or the multiplication of those two numbers. You also need to add a method called print output that prints the summation or the product from the add or multiple methods to the debug log, which means that any output that comes from this has to be printed to the debug log via this method, right? So a quick hint for you guys, you know, add, multiply, and print output are basically private static methods. However, there also has to be a public instance method called do math. The do math is what will get invoked from the execute anonymous window. With that, I conclude this session. I come to an end of the session. However, I will open up the floor for questions. I know the team, Apex Hours team members are doing a phenomenal job answering questions. But I'll quickly pause my screen and check if there are any unanswered questions.
So one good question, Jigar, here. Would you like to answer access specifier, public, global, private, and all?
Okay. So I think I mentioned that, but I'll try to answer that. Let me just quickly open the chat window. Okay. Basically, private, public, and global, these are access specifiers that restrain or limit the access of variables and functions to a class or to only known classes. See, what happens is in the real world, when you're writing programs, it's not just one simple class that you are writing. There are tons and tons of classes, and you want to make sure that uh, the classes or variables are accessible only by the valid other classes, or only certain variables are accessible outside the class. And that is exactly the reason why these access specifiers hold true and come into play. Now, the private access specifier is nothing but when you mark something as private, it is only accessible by members and methods of that particular class itself. Nobody outside that class will be able to access neither those member variables nor those member functions. Anything which is marked as public is accessible also by the entities inside that particular class, and even from outside the particular class. So if you had one class which is calling another class and it was trying to access a public method, it would be able to do that. But the same in the same case, the outside class would not be able to access the private member function. Global is basically about there's a concept of namespaces that comes into play. So when you typically do managed packages and you have uh, classes being shared across, or you want the class, so let's say you've put a class uh, in your product or package which you want people to be able to use so that they can access and use the methods within that. In that case, you would mark the class within your product or package as global so that it is accessible outside the package. Okay, I hope that answers your question. I think with that we've come to an end of this particular session.
Jigar, Mitisite, before we call off, can you explain once about instance and static variables? And there was a query that just I got a ping in private window.
Okay, sure. I'll just quickly explain that. So let me just go back to my slide, which says static and instance. So basically what happens is uh, member variables within a class or the member functions within a class can either be static or instance, right? And the reason why you need that is uh, the both behave in a very different way, right? One of the first things is anything which is instance based is defined by the number of is dependent on the instance which is basically invoked or created with a new keyword, right? But for a static method or a static variable, you don't need to do that. You can just it's basically loaded in memory when the class uh, when the class itself is loaded. Static variables are loaded and static methods are loaded once, or they exist only once, versus because instance variables are object based, right? Every time a new instance is created, a copy of those variables and methods is created. Versus in static, it's only available because it is associated with a class. It is only one, right? The syntax for class calling a static method is fairly simple. You prefix the actual static method with the static keyword. In this particular method, when you define the method, right, you would when you would add the body of the method, you would say public static method name. So this is the method, and if I wanted to call it, I would just use the class name dot method name convention to call it. However, for an instance method, you can't really directly call it by the class name. You actually need to uh, create an instance using the new keyword that, and you define a variable of type of that complex type, and use that variable, which is m1 in this case, to call the method, which is the instance method. So this is the bare minimum difference or the basic difference between static and instance. Okay, most of the times when you're writing a class and when you want functionality which is very closely knit with that class, then you would use an instance method. But if you wanted to have a very common behavior across all the classes, that would end up being put as a static method. All right, I hope that answers the question. uh,
Thank you so much, Jigar. And I will request everyone, like we will post the recording soon. People are asking, need help for assignment. I will recommend once the recording will be available, you can watch the recording again, and that recording will be definitely help you